In this session, we're going to solve equations with rational exponents. For our first example, we have solve x to the 2/3 is equal to 16. Now, generally when we're solving equations, the name of the game is to undo what's being done to the variable. I'm going to change that up just a little bit. I mean, it's true we're doing that, but it's hard to think of it in that context or in those terms. What I want to do is I want to think of the idea of I'd like the exponent on the variable to equal 1. And the way I'm going to be able to do that in the case of having x to the 2/3 is if I multiply the exponent by 3/2, the reciprocal of 2/3. So what I've done is I've written this expression with parentheses and then put the exponent on the outside using properties of exponents. When we have a power raised to a power, we multiply the exponents. We need to remember that whatever we do to one side, we have to do to the other, and so I also need to raise the 16 to the 3/2 power. But now we need to talk about the meaning of the exponent. In the numerator of the exponent, the 3, that means we are cubing. In the denominator of the exponent, the 2, that indicates a square root. And whenever we square root both sides of an equation, we have to remember plus or minus. So we may have been able to stumble our way through getting that 3/2, understanding that we wanted an exponent of 1 on the x. We may have missed out on the plus or minus. In any case, on the left-hand side, x to the 2/3 to the 3/2 is x to the first power, or simply x. On the right-hand side, we have the plus or minus. And what I tend to do is apply the root before I apply the power. So in our heads, 16 square rooted is 4. And then apply that power, we end up with 64. So the answer is x is equal to plus or minus 64. The next example has us looking at this pretty much in the same way. Y to the negative 3/2 is equal to 125 is the equation that we're solving here. I'm going to rewrite this equation. Y to the negative 3/2 is equal to 125. And then, same thing as before, I want the exponent to be a 1. The exponent is currently negative 3/2, so if I multiply that exponent by its reciprocal, negative 2/3, then the exponent on y will be 1. Whatever we do to one side, we have to do to the other, and so I need to apply that negative 2/3 as an exponent to the base of 125. Now, looking at the different parts of the exponent that we have a negative 2/3. That negative is going to indicate a reciprocal. That 2 is going to indicate the power, and that 3 indicates a root. As such, our answer is going to be 1 over something. As before, I'd like to take the root first. So the cube root of 125 is 5. Then I'd like to apply the power. We end up with 25. Finally, reminding ourselves that we had taken a reciprocal, we end up with y is equal to 1 over 25. Now, before you put an APB out on the plus or minus that we talked about a minute ago, it doesn't apply in this situation. Reason being, our root is an odd root. We only need to consider the plus or minus when our root is an even root. Okay, why don't you solve this one? T minus 1, the quantity to the negative 1/3, is equal to 1/4. So in keeping with what we've done before, I've raised both sides to the negative 3rd power. What that's going to do on the left-hand side is multiply negative 1/3 by negative 3. That'll give us an exponent of 1 for the base of t minus 1. In other words, we get rid of the parentheses. On the right-hand side, we have a similar situation to what we had before. That negative is going to indicate a reciprocal, and then of course 3 means that we're cubing. So we're going to flip 1/4, 4, cube it, and we get 64. So we end up with t minus 1 is equal to 64, which ultimately means that t is going to equal 65. Why don't you do this one as well? We have the quantity 2u plus 1 to the 2/3 power is equal to 3. So it looks to me like we're going to apply 3/2 as an exponent to both sides. That'll again give us 2/3 times 3/2 as the exponent on the left-hand side. That'll give us the base of 2u plus 1. On the right-hand side, we have 3 to the 3/2 power, and hopefully we remembered that the denominator of that exponent, that 2, indicates square rooting. When we square root both sides of an equation, we have to throw in plus or minus. So I generally like to apply the root before the power when I have a rational exponent, but sometimes it's just not feasible. In this case, because the square root of 3 is not rational, what I'm going to do is actually interpret this as the square root of 3 cubed, so the square root of 27, which I'm then going to simplify. We have 2u plus 1 is equal to plus or minus 3 times the square root of 3. Then subtract 1 from both sides. We get 2u. I'm going to put the -1 first, kind of like something that would look like we got it out of the quadratic formula. -1 plus or minus 3 times the square root of 3. And since this is not a complex answer, it's okay to go ahead and write this as u equals -1 plus or minus 3 times the square root of 3 all over 2. If you really wanted to, you could split this up into two fractions. You'd have u equals -1/2 plus or minus 3 times the square root of 3 over 2. Notice each term needs its own denominator of 2. Either of these would be correct. I'm just going to go ahead and circle the first one and be content with that. Oh, holy cow. Here we've got solve 4 times x plus 1 to the 1/2 minus 5 times x plus 1 to the 3/2 plus x plus 1 to the 5/2 is equal to 0. This is a different critter. What I do see is a common factor in all three terms. And so I'm going to factor it out. You may recall from factoring things that when you do so, you end up factoring out the common factor with the smallest exponent that appears. In this case, the smallest exponent that appears is 1/2. So I'm going to factor out x plus 1 to the 1/2, and then I'm going to use a square, if I can draw one, square bracket for what's left. In the first term, I've factored out the whole x plus 1 to the 1/2, so I'm just left with 4. In the second term, 5 times x plus 1 to the 3/2, with a negative in front of it, I have factored out x plus 1 to the 1/2, which means I should subtract 1/2 from the exponent of 3/2. That leaves me with the middle term of -5 times x plus 1, and if you like, to the first power. Likewise, that third term, we're going to factor x plus 1 to the 1/2 out of it. That means we're going to subtract x plus 1 from the exponent of 5/2. And we're going to end up with x plus 1, the quantity squared, right? 5/2 minus 1/2 is 4/2. All of that equals 0. Now I'm going to rearrange this. We have the x plus 1 to the 1/2, and rearranging gives me times the quantity of x plus 1 squared minus 5 times the quantity of x plus 1 plus 4 is equal to 0. Now, I don't know if you recognize this, but maybe you do. I see something that's quadratic in form. And so I'm going to factor what's inside the brackets as a pair of, well, I would say binomials, but that's not how it's actually going to work out. X plus 1 and x plus 1 inside of each set of parentheses. And then I'm looking at the -5 as the the second coefficient, and the 4 as the third coefficient, and recognizing that this is going to factor into x plus 1 minus 4 and x plus 1 minus 1 is equal to 0. Don't forget the x plus 1 to the 1/2, it comes along like a nagging baby brother. You just can't get rid of it. Now, simplifying what I can, I have x plus 1 to the 1/2 times x minus 3 times x is equal to 0. Now I have three factors which when multiplied together give me 0. Any one of them could be 0. And so x is equal to -1 from the first factor, 3 from the second factor, or 0 from the third factor. For our last example, we have x to the 1/2 plus 3x to the -1/2 is equal to 10x to the -3/2. I again see a common factor. The base is x, and then we've got some exponents running around. There are a couple of different ways we could look at this. In both cases, I suppose we would start out the same way. So I will get everything on the same side. X to the 1/2 plus 3x to the -1/2 minus 10x to the -3/2 is equal to 0. And one way we could look at this is recognizing that the negative exponents indicate fractions. And so we could multiply both sides by x to the 3/2. If we did so with all of the terms, well, x to the 3/2 times x to the 1/2 is going to give me x squared. X to the 3/2 times 3x to the -1/2 is going to give me 3x, because we were adding the exponents, right? 3/2 minus 1/2 is 1. Finally, 3/2 times -10x to the -3/2, adding those exponents gives me a 0 as an exponent on x, and so that factor drops out. And though I neglected to illustrate it, x to the 3/2 times 0 is still 0 for the right-hand side. Next, we're going to factor x squared plus 3x minus 10 equals 0. And we get x plus 5 times x minus 2 is equal to 0. So x is equal to -5 or 2. Or is it? Remember when we started out, we had x to the 1/2 among other things. That x to the 1/2 indicates, it means the square root of x. That being the case, we can't have a -5 as a solution. Therefore, the only solution that we end up with is x equals 2. Now I said we would look at this in a couple of different ways, so let me rewrite the equation. And as before, get everything on the same side by subtracting 10x to the -3/2. And now we're going to approach this like we did last time, recognizing that we have a common factor among all the terms. Using the smallest of the three exponents, -3/2, I'm going to factor out that x to the -3/2. And what this means is I'm now going to be subtracting a -3/2 from each of the exponents. Subtracting a negative looks a whole lot like adding. So we're going to end up with x to the 1/2 minus a -3/2. That gives me x squared. Second term, 3x to the -1/2 is how it started. -1/2 as the exponent minus the -3/2 because of what we're factoring out is going to equal 1. So I have 3x. Finally, what I'm factoring out is x to the -3/2, which is the thing that 10 is attached to, the expression that the coefficient has. And so that disappears, or factors out completely from the third term, leaving us with -10 is equal to 0. This is going to finish the same way as before. We have x squared plus 3x minus 10 is equal to 0. But one of the things that I want to point out in this case, and it's a common pitfall, is people see the x to the -3/2 if they've factored it out, and they think, oh, x must equal 0. As a matter of fact, x cannot equal 0 because the negative 3/2 as the exponent indicates that that x is in the denominator. Our final answer, x is equal to 2.